Let's have a look at parallel line geometry now. And this is a part of geometry that's basically around parallel lines and transversals. So transversals are the lines that cut the parallel lines. And parallel lines, if you can recall, are lines that run in the same direction. Okay, and they're indicated by these arrows. Okay. There are three sets of angles that we consider. Okay, so when you have a pair of parallel lines, or even three parallel lines, but we'll just consider the pair of parallel lines, and we cut them with a transversal, that forms basically a set of angles. Okay, so let's have a look at the first set of angles that it forms, and they are called the alternate angles. Okay, and the reason why they're called alternate angles is because the pair of angles that are formed are basically on opposite sides of the transversal. And also, one of the angles is either above a parallel line, the other's below. Okay, so totally opposite in every way. So if you take, for example, the arc here in black, okay, notice that one of them is one of these arcs is to the left of the transversal. The other one is to the right of the transversal. Okay, in fact, just to make it a little bit clearer, I'll just zoom in on that there. Yep, it's probably a little bit easier to see. Take the red arc. Okay, one arc is above a parallel line, the other's below the parallel line. This arc is to the left of the transversal. This other arc, the red arc, is to the right of the transversal. The blue X's, same thing. They are also alternate. And the green dots are also alternate angles. Alternate angles are also equal in size. So this angle here is the same size as this angle here. This blue angle here is the same as this blue angle there, and so on. Now, the next set of angles that we're going to look at are the corresponding angles, or the corresponding angle pairs. Now, very different to alternate angles in their positioning. So let's look at the black arcs. Notice that this time around, instead of being one on one side, one on the other, they're both on the same side of the transversal. Okay, so both of these are on the right hand side, for example. Also, both of these angles are above each of their respective parallel lines. Okay, so that's why they're called corresponding. They both correspond to basically the same position or the same placement compared to the transversal and compared to their parallel line that they sit on. Okay, so either they're all above or all below. So take the blue arc, for example, on this blue arc there. Both of these arcs are to the left-hand side. Okay, so both on this side, and both of these arcs are below the parallel line. So again, as one moves, the other has to move with it too. So the red dot, for example, one dot's above the parallel line, the other corresponding red dot is also above a parallel line. This dot at the top, the red dot, is to the left of the transversal. This other dot is also to the left of the transversal. So that's why it's called corresponding. Again, corresponding angles are also equal in size. Okay, so last one are the set of co-interior angles, or the co-interior angle pairs. Co-interior kind of means exactly that, interior. So they actually form kind of like a C shape. Okay, so they're not the only co-interior angles. But let's have a look at these arcs here. So you see how that's a single black arc. That's a double black arc to indicate that they're actually two different sizes. Okay, so they're potentially, well, there's actually one example where they're not, but typically they usually are different size. So the only thing with co-interior angles is that the sum of the co-interior angles is 180 degrees. They are in fact supplementary. So the blue, for example, the blue dot and the blue cross, okay, again, they fit inside the parallel lines, and again, on one side of the transversal, they add up to 180 degrees, okay. The only time where for example, the dot and the cross would be equal in size would be if they were both 90, okay, so 90 plus 90 would be 180, but that's not always the case, all right. Another example of co-interior angles would be, for example, the red dot and the red cross. Okay, that's another example of co-interior. Even though it sort of looks like it's exterior, they're still considered co-interior angles. And also the green single arc and the green double arc, again, they're also co-interior angles too. And the sum of those would also be 180 degrees, so that'd be supplementary as well. So basically, to summarize, okay, right, alternate and corresponding angles are equal in size. Co-interior angles are supplementary, okay, which means that they add up to 180 degrees. Now in the next video, we'll have a look at a few examples of alternate, corresponding and co-interior angles in problem solving involving parallel line geometry.